Welcome back to Fat Mama Physics. This is part 2 of gravitational potential energy. With me today, I do have two little mascots to be part of our storyline, Shin and Lulu Pig. Lulu Pig loves Shin's singing. His voice is absolutely angelic and stunning. And they are going to be my two masses that I will use in this video. Typically, I'll refer to Shin as mass 1 or the bigger mass, and then Lulu Pig as the smaller mass. The purpose of this video today is for me to go over what gravitational, put more context into gravitational potential energy, what this negative sign means here in this equation, what does it mean to increase gravitational potential energy, decrease, what does it mean when it's positive or negative, how does this infinity concept play into the reference point, and so forth. This is to bridge from the previous video in which we talked about the definition of gravitational potential energy and how we quantify that using calculus. Just to reinforce, you do not need to be able to derive this equation using calculus, although the appreciation of that would be something that's desired maybe later in this course. And the key to redefine gravitational potential energy is to talk about how we as the surface of the Earth is no longer special, and we need to redefine where that reference point is. So to redefine that reference point, yes, it has something to do with infinity. So one of the things that I want to highlight is this new reference point. Okay, so new reference point being at infinity, we can start off with our equation that we've derived or discovered in our last video. If we talk about infinity, let's look at what happens to the gravitational potential energy when we talk about infinity. When this R approaches infinity, let's say, then this bottom number, the denominator, becomes really big. When the denominator becomes really big, that means you're dividing by a very big number, so your whole fraction then becomes much smaller, which means whole thing is going to tend to 0. And this is the point that I want to set over here, in which our new reference point at infinity means that our gravitational potential energy is going to approach 0 joules as R approaches infinity. This is a very interesting reference point because no matter where you are in the universe, we all kind of agree that infinity is just somewhere really far out there. It's almost as if everyone in the universe can associate equally with that, regardless if you're on the Earth or if you're Alpha Centauri or you are, or you're at SGRA, which is the black hole at the center of the Milky Way. Anyway, anywhere in this universe we can kind of associate with infinity being our agreed upon point. Now, because I love graphs, I'm going to use a graph to kind of talk about increase and decrease in gravitational potential energy. So here I have Earth, of course. That's my really ugly drawing of the Earth, but I hope you kind of get the idea. So, which means you have the radius of the Earth, and then the mass of the Earth as ME, which, you know, don't need quantities so much yet, but just give you some sense. So if we are going to graph negative big G, big M, small n over R, we have an inverse graph, but it is flipped on the x-axis. So what that looks like is, it looks like this. Now, one of the key things about this graph is as R approaches infinity, you'll notice that this graph has an asymptote at y is equal to 0, or when this line approaches the x-axis, it will always, it will never cross over the x-axis. It will tend towards 0. So gravitational potential energy then reaches 0 joules. And this is in accordance to what we talked about earlier. Okay, so before I talk about increasing and decreasing gravitational potential energy, I think we need to really highlight the negative sign in the gravitational potential energy. And why is there a negative sign? Aside from the fact that calculus or math told us so, but what is the physical significance of this negative sign? I have 3 reasons to give us. I'll start with the first one. I know that I mentioned in the previous video, notice I erased all that crap that I wrote over here, that it was improper to use work as a way to interpret this function, since work implies that the force that's multiplying by the displacement, that force had to be constant, or it had to be some sort of average value, which we can't achieve in this case, since force of attraction is constantly changing as you're moving your 2 objects together or further away from each other. But one thing that I want to highlight here is, by the definition of this work, the force and the displacement had to be in the same direction. And that's how this was introduced to you when we studied classical mechanics. But let's think about it. We have Shinshin and Lulu Pig. Lulu Pig loves Shinshin. I don't know about the other way around, but imagine they are, if you're trying to, imagine you're trying to bring them together from infinity to a point R of separation. Now you kind of want to think, is it easy to do that, or is it really hard to do that? I kind of have to assume both of them have equal infinity to each other. I mean, they both have mass, and of course anything has mass is attracted to the other object that has mass. So if you're trying to bring them together from infinity, you kind of don't need to do anything. They will just naturally come together due to random motion. You know, they as long as they get a little bit closer to infinity, then over a long period of time, they're eventually going to end up together. Okay, because both have mass and both masses are going to be attracted to each other. But that also means that if I am an outsider and I'm trying to force these 2 masses together, not only do I need to put in force, I kind of need to drag them apart as they're coming together. Okay, because if you think about it, when we talk about work, we're just talking about change in gravitational potential energy. We're not talking about change in kinetic energy. So essentially, if I want to bring them closer together at constant speed, meaning their speed is not changing, okay, I kind of have to drag one of these guys or both of them apart from each other. So I'm kind of like pulling on one backwards just so they don't ram into each other. Even though they're being displaced together, the force that I'm applying against them is in opposite direction to their displacement as they're coming together from infinity. So here I have a drawing of Shinshin is on this side because I associate Shinshin with heavier mass, or the bigger mass, sorry, not heavier mass, bigger mass. And then Lulu Pig has the smaller mass here. So if we're moving them closer together, so technically Shinshin should be all the way over here. But anyways, if we're moving them together, or if I'm moving Lulu Pig, technically, yeah, let's move Lulu Pig. If I'm moving Lulu Pig closer to Shinshin, then our displacement is towards Shinshin. But remember, Lulu Pig loves Shinshin. So I have to apply a force in the opposite direction. So notice that the force and the displacement are, they're in different directions. Okay, so Lulu Pig's like, I want to get you, and I gotta apply a force in the opposite direction. Now, what that means is, if I have the force and the displacement in the opposite direction, that means, if you recall from the definition of work, which is cosine theta is, or theta is 180 degrees, which makes this whole thing negative, okay? Or you can just say that the fact that the force and displacement are in opposite directions, therefore, there is a negative sign in front. So here, force is opposite to displacement. The reason for that is Lulu Pig and Shinshin have a force of attraction towards them. So I need to apply an equal and opposite force to that to move Lulu Pig at a constant velocity towards Shinshin, and not have them just accelerate towards each other. Okay, on to the second reason. Now, let's go back to Shinshin and Lulu Pig. Now, if I apply this force, and this goes back to what it means to apply for energy or for work to be negative. If I'm trying to apply a force on Lulu Pig so he doesn't rush towards Shinshin, then what I'm doing is I'm taking away all that kinetic energy that Lulu Pig would have gained if I allowed Lulu Pig to accelerate towards Shin Shin. Okay, so by taking away energy from the system means that the work that I'm doing is by definition negative. So the work that I'm doing in bringing Lulu Pig closer to Shin Shin is I'm taking away kinetic energy that Lulu Pig would have gained. Because remember, I gotta bring them in together at constant velocity, and that's what it means to put them in based off the definition of gravitational potential energy. So really, reasons 1 and 2 just highlights what it means for work to be negative. Reason number 3 has to do with the fact that if we bring objects closer together, by definition, gravitational potential energy should decrease as you bring objects together, and gravitational potential energy increases as you bring them further apart. So if this is where I'm going to go back to this graph again. If we start off as two objects being from infinity, this is where gravitational potential energy is 0. As we bring them together, as gravitational potential energy decreases between your two objects, that means we decrease EP from 0. If we decrease EP from 0, then it would just be negative if you're decreasing from 0, right? Based on the number line, you have 0, and as you decrease from 0, it becomes negative. And this one I can't really write really well, so I'm just going to type it. And this number 3 point has to do with the fact that we set the reference point at infinity. If we set infinity as the reference point where EP is equal to 0 joules, then EP must decrease as you move masses together. Decreasing from 0 joules means your EP becomes negative. Okay, I'm just going to leave it there, and I'm going to draw this. So the third reason has to do with the fact that we've redefined where that reference point is. So if we go back to gravitational potential energy, as you move objects further away, you increase their gravitational potential energy. So if we increase gravitational potential energy, let's use this graph. Let's say they're very close together, okay? So we're talking about here. And as you increase their gravitational potential energy, as they move further apart, we are going towards the right of this graph. So your EP becomes less negative. Less negative also means increasing, right? So that's kind of a new, kind of a weird thing that students get a little mixed up, is as you increase gravitational potential energy, your EP becomes less negative, even though the value itself still is negative. If you bring objects closer together, you are then decreasing gravitational potential energy. So then moving towards the left relative to where you're seeing on the screen, this is becoming more negative, and becoming more negative also means decreasing as you're becoming more negative from the number line. Think about the number line. And again, all of this has to do with the fact that, sorry, surface of the Earth, we're no longer special. Okay, we are now redefining infinity as our new reference point. And this is where all of these ideas stem from. Anyways, that concludes part 2 of gravitational potential energy. And of course, we want to say thank you to our 2 little mascots, Shin Shin and Lulu Pig. I hope to be back with some examples, and maybe you will see them back in further episodes. Hopefully you got something out of this video. Hopefully it makes a little bit more sense. And I hope you all the best with studying this topic at your own pace. I wish you good luck, and Fat Mama Physics signing out.